So today we're looking at converting from one unit to another. So converting inches to feet, converting meters to centimeters. We'll look at both customary measurements and we'll look at metric measurements. And first we'll take a look at customary. So customary measurements are basically measurements that we use in sort of everyday life. So feet, ounces, pounds, cups, gallons, those sorts of things. Those are all customary measurements. Miles, all customary measurements. And the way we convert these units from one to another is we use something called a conversion factor. And what the basic premise of all conversion is this single multiplication problem. You take the value that you have, so however many things you have right now, you take that value, you times it by this conversion factor, which will be a fraction, and you get your new value. So what is this mysterious conversion factor? Well, the conversion factor, all this is telling you how many new units for how many old units. This is basically telling you how many feet are in an inch, or vice versa, or how many feet are in a yard, or how many cups in a gallon, or how many quarts in a pint, or pints in a quart. So your conversion factor is simply something you're given or you have to memorize that allows you to go from one unit to another, and then you just multiply that by whatever you have. So here, usually the conversion factor is set up as the target units, the units you want to go to, and the old units, or the units that you're coming from. So for example, we know that there's 12 inches in a foot. If I wanted to go to inches, if I was converting a foot measurement into inches measurements, I would do 12 over 1, because 12 inches is what I'm targeting, 1 foot is where I'm leaving. If I wanted to go to feet from inches, I'd reverse that and have feet on top and inches on bottom. So rather than just kind of talking about this, let me show you here. So we have 30 inches and we want to go to feet. Now we know for a fact that there are 12 inches in 1 foot. That is something you either have to memorize or that you have to be given, if you haven't memorized it, to do this problem. This is your conversion factor right here. 12 inches equals 1 foot. That's your conversion factor. So what I'm going to do is I'm going to take 30 inches, and I'll put it over 1 just so it's a fraction, times my conversion factor. Now I have two ways of setting this up. I can put 1 foot over 12, or I can put 12 over 1. How do I know which was correct? Well, again, I look at my target. My target is to go to feet. So I want the feet number to be on top. So I'll put 1 foot on top, and the rest of my conversion factor goes on bottom. And then you just multiply across. 30 times 1 is 30, and 12 times 1 is 12. Now, the reason that this works is because it kind of makes use of a division property we've used before with numbers. And that is, if you have the same thing on the top and bottom of a division problem, then you can cancel it out. So for example, if I use a different color here just to make it stand out, right here we have inches, and here we also have inches. So just like numbers, these can cancel out, and all I'm left with is feet, which is what I want. I want a target unit of feet. Feet's my target value. So the amount of feet I have is just 30 divided by 12, because I want to make this fraction to a decimal, which turns out to be about 2.5. So 30 inches is 2.5 feet, because I just take the top number and divide it by the bottom number to get my decimal from my fraction. But this right here, this conversion factor, is the key to solving all of these conversion problems. You have to either know or be given this value that you can then manipulate in order to get your end result. So what about gallons and quarts? Well, there are 4 quarts and 1 gallon. Okay. And I want to convert 4 gallons into quarts. So I'm going to start with my value. So this is the value, 4 gallons over 1. Now my conversion factor is this right here. If I want to go to quarts, that means I want to put the quarts number on top. So 4 quarts, 1 gallon. Again, just like before, the gallon labels, just like if there were numbers, they cancel out. And I'm left with 4 times 4, which is 16 over 1, or just 16 quarts. Because technically on bottom, I would do 1 times 1 is 1, but because I already know there's a 1 there, if I just write the 16, I'm fine with just writing this. Whoops. Just writing this. So again, this conversion factor is needed to go from this to the fraction. That way I can multiply and get my answer straight away. If you don't know, ounces and pounds, 16 ounces is in 1 pound. So when I start, I'm going to have my value, 20 ounces. Put it over 1. I want to go to pounds. Well, 1 pound. So 1 pound is equivalent to, whoops, not 16. 1 pound is equivalent to 16 ounces. So again, this conversion factor is simply going to be changed into a fraction that when I multiply, the ounces go away, and I'm left with 20 over 16 pounds. But I really don't want to leave my answer as 20 over 16. It's kind of a bad way of leaving your answer, especially if it's an unreduced fraction. So we're just going to name that 20 divided by 16, which is 1.25 pounds. And remember, that's an LB, not a 1B, so it's 1.25 pounds. Again, this all hinges on the conversion factor's multiplication. And as you get used to doing some of these, you can kind of start to see, okay, here's some patterns that are involved, and you can start taking shortcuts. Like, for example, if you know there's 12 inches is 1 foot, think 30 inches. Well, how many 12s are in 30? Well, all that means is you're going to divide, which is what you do at the end anyway. So once you get using the setup more often, you'll start to see sort of shortcuts that you can take that will then make it do less time next time. What about feet to yards? Again, if you didn't know, 3 feet in 1 yard. So when I set up my stuff, 19 feet is equal to, I want to go 2 yards. Yards is my target label, feet is my old label, so 1 yard and 3 feet. Once again, the feet cancel out, and I'm just left with multiplying my fraction. So 19 on top, 3 on bottom, which just like before means I'm going to end up dividing because I have 19 over 3. Again, some of you might be able to see it here that you're going to need to divide right away. This ends up being 6.3 repeating yards. So again, the conversion factor is the most pressing things here. I should be at times there, my bad. So the conversion factor is how we're going to manipulate all our customary measurements accordingly. So we need to know that conversion rate, that conversion factor, because we use that to set up a fraction that we can then convert later on. Another sort of shortcut here, if you remember, is that if you know the size of the units, like if you know a gallon is bigger than a quart, a pound is bigger than an ounce, a yard is bigger than a foot, if you know that, you can kind of sidestep the whole division multiplication procedure, because the rule of thumb is that, well, for example, for inches, if I have a small unit and I go to a big unit, I'm going to divide by the conversion number. So inches is smaller than feet, so I do 30 divided by 12. Well, here, it's the opposite. Gallons is the bigger unit, quarts is the smaller unit, so I'm going to end up multiplying by my conversion factor. 4 gallons times 4 quarts is 16. Here, ounces is smaller than pounds, so I end up dividing 20 by 16 to get 1.25. And here, feet is smaller than yards, so I end up dividing 19 by 3 to get 6.3. So if you know your conversion factor and you know kind of how much one unit, or if you know one unit is bigger than the other, then you can just kind of divide or multiply depending on what direction you're going. But again, that's kind of a shortcut you'll develop after you do most of this stuff over and over. So starting with the basics here isn't necessarily a bad idea. Now these are all single conversions. They take one conversion factor. Some problems like these might take more than one. So for example, if we take more than one conversion factor, we just have to kind of keep track of how our fractions are going to go. So we'll start with this one. 84 inches is how many yards? Well, let's start with 84 inches. 84 inches. Now, this is going to take me 2 jumps. Now, if you know the conversion rate for inches to yards, then you can do that. But if you don't, it's going to take you 2 jumps. You're first going to convert inches to feet, and then you'll convert feet to yards. Now there is a conversion factor that goes directly from inches to yards, but we'll pretend you don't know that for the sake of argument here. So the first conversion factor is going to go from inches to feet. So I want to put feet on top, I want inches on bottom. And out there's 12 inches for every 1 foot. Again, target units on top. I want to change inches to feet. And then I want to change feet to yards. So I'm going to put yards on top here and feet on bottom there. And I know that there's 3 feet for every 1 yard. So in this case, if I go through my canceling just to make sure I end up with the right label, remember the labels cancel if they're on top and bottom. So this cancels with this cancels with that, and the only label I have left is the label I want, which is yards. So when I end up doing my arithmetic, I get 84 times 1 times 1, which is 84. And I get 1 times 12 times 3, which is 36. And this will indeed be yards. And if I actually do that division, so it's not a nasty little fraction, I end up getting about 2.3 repeating yards. So it's just like converting single units, except that you have to do it twice. You convert once to 1 unit, and then you convert that to another unit. And again, if you don't know the conversion factor directly from inches to yards, you'd have to do it this way. If you knew that there were 36 inches in 1 yard, then you can go directly from inches to yard without having to go with the foot conversion there. But if you didn't, you'd have to go inches to feet and then feet to yards. Same thing as for gallons and pints. So again, if you don't know that there are 4 quarts in a gallon and there are 2 pints in a quart. So when I start this, 8 gallons over 1, I want to go gallons to quarts to pints. That's the conversion. Gallons to quarts to pints. So I want to go to quarts first, and I know that there are 4 quarts in 1 gallon. That should be a times, not an equals. And then I want to go from quarts to pints. So pints is PT. And now note that there are 2 pints and a quart. So when I do my arithmetic, it's going to be 8 times 4 times 2. Or 4 times 2 times 8 if you prefer. It doesn't matter the order you multiply them. Anyway, 8 times 4 times 2 is going to end up giving me 64 pints in those 8 gallons. Again, it's 64 over 1 technically, but I don't need to write the over 1 part because it's 8 times 4 times 2. And again, if we check here, my cancellation should give me the correct label at the end. Gallons goes away, quarts goes away, and I'm left with just the one I want, which is pints. So that's how you can kind of check yourself before you go through all your multiplication, is cancel out your labels and make sure you end up with the right label at the very end. If you end up with something else, or if you don't cancel out all your labels completely, that means you probably missed a conversion factor somewhere along the routine there. Now, again, those are all customary measurements. Metric measurements use a little bit of a different thing. Metric was designed specifically to be easy to convert. So its conversions are typically a lot easier. It still has conversion factors, but the good thing about the metric is that every conversion factor is based off of a power of 10. So for example, if I start with the label meter, a meter is kind of the base unit for length in the metric system. Things are based off of meters. If I want to go for a decameter, I simply take a meter and times it by 10. That's 1 decameter. 1 meter times 10 is 1 decameter. So there are 10 meters in 1 decameter. There are 100 in 1 hectometer. And there are 1,000 in 1 kilometer. So 1 kilometer is worth 1,000 meters. 1 hectometer is worth 100 meters. 1 decameter is worth 10 meters. And the backwards is true as well. There are 10 decimeters in a meter. There are 100 centimeters in a meter. And there are 1,000 millimeters in a meter. So 1 meter contains or can be split into 10 decimeters. 1 meter can be split into 100 centimeters. And 1 meter can be split into 1,000 millimeters. But again, all these conversions are based off of powers of 10. So because of that, whenever I times or divide by a power of 10, all that happens is I move the decimal. So instead of doing this big, long conversion factor multiplication process, since it's always going to be powers of 10, I just simply need to know where is the decimal going to end up from where it's at. And to use that, we use this little mnemonic here. Kids help daily, but don't clean much. That helps us remember the order of the different values. And all you do to convert metric system is you figure out which letter or which value are you starting at, which value are you ending at, how many jumps, and what direction does it take to get from start to end. Let me show you that in action. So we have our chart here. 120 meters to kilometers. Remember, our decimal's back here. So I'm starting at meters, which is my base unit here. So base unit stands for meters, liters, and grams. It's kind of the unit without any prefix on it. I want to go to kilometers, which right here is K. So I'm going to say it takes me 1, 2, 3 jumps to the left to get from base to K. So I'm going to mimic that on my decimal. 1, 2, 3 jumps to the left, and I have a 0.120 kilometers. Again, this is because there are 1,000 meters in 1 kilometer, so what I essentially did by moving left 3 times is I divided by 1,000, because I'm going from base to kilo. So I end up dividing by 1,000 to get to there. So this is just kind of a shortcut way of doing the conversion factors for the metric system, because the metric system is nice and based off powers of 10, which when you multiply and divide, all they require you to do is move the decimal. Unlike customary measurements, where when you have to convert using some sort of awkward conversion like a 12 or a 3 or a 6 or a 4, where the division doesn't end up as easy as just doing a 10. So a metric system was designed to be easily converted, which is why we have this little side cut here. And it works for any values that you need in the metric system. Again, only for metric system, but works for any of them. So for milliliters to liters. So I have 60 here, but my decimal point at the end if I don't see it. Milliliters starts with M to liters. So starts with B. Let's check. 1, 2, 3 jumps to the left once again. So 1, 2, 3 jumps to the left. Again, there's an empty loop here, so I put a 0 in place there. And my new label is 0.06 or 0.060 liters. That's how many liters are in that many milliliters. Again, no multiplication needed, no division needed, just a simple move of the decimal. What about this next one here? This one actually gives me my decimal. I can actually see where it is. I don't have to put it in myself, which is nice. 12.56 hectograms over here to centigrams way over here. Well, let's count the jumps. 1, 2, 3, 4 to the right. All right. 1, 2, 3, 4 to the right. Again, empty loops are filled in with a 0. So this becomes a rather large number. 125,600 centigrams. But again, no need to do a conversion factor, no need to multiply or divide. This table is basically just a shorthand way of doing that all in one go rather than setting up formally. And again, this can only happen for metric system because dividing and multiplying by tens, all that happens is the decimal moves anyway. So we're just kind of focusing on the part that matters when dividing or multiplying by 10 rather than actually doing it step by step by step. So that is converting units. Again, 2 units, 2 different ways. Converting customary measurements is when you take the conversion factor and you multiply it to get your new value. And then metric system is simply when you jump the decimal either up or down to get from one value to another. Hope you enjoyed the video. Have a good day.